My name is Chad, and I'm a product manager on the BigQuery team. Hey, thanks for spending a bit of time with me. Today, we're going to be talking about data and analytics, and we're going to be talking about data analytics infrastructure and how you can get that infrastructure running at your company without busting the budget. So, I hope you're all well and safe, and these are very strange and somewhat dire times. The coronavirus pandemic is putting a lot of new pressures on us, both personal and professional. As a sign of the times, I'm recording this webinar from one of Google's recently commissioned satellite studios, otherwise known as my home office. On the professional side, the coronavirus is putting brand new pressures on our businesses. Obviously, work from home is putting, case in point, right, is putting new pressures on video conferencing, video recording, as well as modern productivity tools. On the analytics side, work from home is also putting new demands on things like do-it-yourself dashboards and getting better and easier access to the underlying data underneath those dashboards. So there's an issue here, right? The demands are going up or changing or going up, right? And the risk in the world or in the marketplace right now is causing tightening pressure on budgets. So demands are going up, budgets are going down. That's a bit of a rock and a hard place for us to navigate. And so in particular, some of these questions that we have to address as we navigate this time is, are these, can I meet analytics demands on a shrinking budget? How do I effectively increase business agility and efficiency? How will consumer behavior change, and how do we prepare for that? And can I ensure sufficient data privacy and data security? So as we think about these, and as we think about these in the context of analytics, really at the center of any data analytics workflow is the data warehouse. And so data warehouses, particularly on-prem data warehouses, tend to have some issues when they get stressed, like they're getting stressed in these current times. They're expensive to procure and maintain. They can be increasing the scale of your data warehouse can be a tricky thing and can take a long time or be costly. Stale information is also a problem that the traditional data warehouses may not support enough capacity to stream and get your analytics out in real time. Limited insights is another one. Adding new data or new streaming data to your data warehouse is one thing, but also adding new technical capabilities to, say, run ML models on your data warehouse can also be a challenge. And then lastly, with your workforce remote, the lack of secure sharing can be a real problem because those generate data silos. The cloud does offer some answers to some of these constraints, particularly with the elasticity of compute and storage that's available in the cloud. We can generate fully managed and elastic scalable platforms. We can build in high technology like machine learning, geospatial analysis right into the data warehouse. All of Google's systems are baked with security and reliability at the core of their implementation. And as we'll talk about in a little bit, we can also offer this at a lower cost of ownership than a traditional enterprise data warehouse. So let's spend a moment and we'll talk about Google's Smart Analytics platform. So the way this, it's a busy diagram, but give me a second, we'll go through it. Data runs through this from left to right. So you have streaming batch into the right-hand side, and then you can see on those blue boxes there are a number of different stages along the journey of data, from collection to process, storage, analyze, and then visualization, sharing your BI and vertical apps over on the right-hand side. In this talk, we're going to dive most specifically into BigQuery, which, as we said, is the data warehouse that really forms the center of this analytics pipeline. So BigQuery is Google Cloud's enterprise data warehouse for analytics. The thing that's really special about this product is that it can scale from very small data sizes to extraordinarily large data sizes without the user needing to really worry about procuring extra capacity. Google's serverless and fully managed functionality handles that for you. So on the top right there, this fully managed and serverless for maximum agility, that's really the the core proposition, the core value proposition of BigQuery. Now, we do have some other ones as well. We do streaming data, and between the real-time insights and then the bottom one on the bottom right there, the BI engine, we do streaming data and high velocity dashboarding exceedingly well. And then in the middle there, we have built-in functions like machine learning and geospatial that are built right into the data warehouse so that you can do as many different kinds of analyses in the product as you want. Some of our largest customers have data warehouses in the hundreds of petabytes and run queries over tens of petabytes at one time. Some of our smaller customers have data warehouses in the gigabyte size. All of them can be handled effectively by the infrastructure that BigQuery is. So let's talk about for a moment what benefit that serverless and fully managed data warehouse actually affords to you. The image on the left here shows how folks spend their time if they're working in a traditional data warehouse. I'll say 15% of the time is doing the really valuable work of analysis and generating insights. The rest of the time is all managing the data warehouse, monitoring, provisioning, performance tuning, etc. By abstracting away a lot of those functions inside the data warehouse, BigQuery allows users to focus mostly on analysis and insights, which is the purpose of having a data warehouse for analytics. We can also offer that benefit at a very cost-effective price point. So the ESG did a study to compare the total cost of ownership over 3 years of BigQuery and then several of our cloud competitors. And we found that BigQuery was 34 to 26% less expensive over a 3-year TCO than our cloud competitors. So, the product can process enormous amounts of data with cutting-edge technology, and it's less expensive than the competitors. Now, here's how you actually go ahead and manage some of these some of the cost here. We have 2 pricing structures available, pay-as-you-go and flat rate. Pay-as-you-go is essentially on-demand pricing. You pay for the queries you run, you pay for the data you store. If you stop running a query or if you delete all your data, your bill stops. It's just over. Companies that are either just starting out or smaller enterprises tend to prefer this pricing model because it's exceedingly flexible and fluid. Companies that are a little bit further along in their cloud migration or in their engagement with Google tend to prefer flat rate. With flat rate, you can buy a specific amount of compute capacity. We refer to these as slots. The middle bill here has a little bit more detail. A slot is a certain measure of compute power, a certain measure of RAM, and a certain measure of networking in our data center. And so the more slots you buy, the more throughput you get, the more bytes you can process in a given amount of time. And so you can kind of walk through this flow chart on the right here and ask yourself, are you enterprise scale? If yes, do you want to go towards cost predictability and engage with the flat rate? If no, you might prefer to leverage on-demand pricing. Now, what's important about the flat rate pricing, though, is we've gotten feedback from customers that while they want the predictability of flat rate, they still want to be able to control their capacity. And that's what BigQuery Reservations brings to them. So you can control your flat rate spend, you can scale it up, you can scale it down, and you can manage your workloads across the different reservations of capacity that you have. You can also automatically share any unused capacity with other groups inside your organization. The other big feature request that we got in this domain was around being able to burst or have flexible slots. And so the screenshot, it's actually a screenshot from our UI where you can go and select or purchase capacity or slots. And you see in the dropdown there that you can purchase monthly, annual, or flex. So monthly is you buy a certain amount for a given month. Annual, you get a discount if you commit for a year. That's awesome. And flex, if you just need a bunch more slots for Tuesdays because that's when you run your reports, or if you need to flex up your number of slots on Black Friday, if you're a retailer, you can do that. Flex slots is you can provision them in seconds and you can cancel them after 60 seconds. So this is literally by the minute scaling up or scaling down the amount of capacity that you need. So we're very excited about this because now customers can programmatically increase or decrease the amount of compute that they have. So hopefully I've motivated this sentence well for you in that BigQuery provides cost-effective analytics and resource management so you can get more insights for less money. Our customers have been doing just this. So I won't go through all of them. We'll deep dive into a couple here though. So in a variety of different verticals and a variety of different markets, our customers are coming to us and getting value out of the product. So from Home Depot and Zulily in retail to 20th Century Fox in media and HSBC in finance and banking, they really span the gamut of applications of a data warehouse. So here's a little detail on Home Depot's story. I'll leave you to read some of the benefits they got, which are listed on the left there, and I'm going to focus on the quote. We migrated our enterprise data warehouse to BigQuery, and that was a huge effort, but it was a tremendous success for our company. I really wanted to dive into this one because it's important. I don't want to minimize the effort here of a migration. It's not a trivial endeavor to undertake. There are real benefits, as you see here listed on the left. There are real benefits to doing it, but it's a bunch of work. And through accompanying many customers through this, Google has not only honed the products to make migration easier, but we've also honed the programs and the support that we have available to make the migrations as fast and efficient as possible. So we'll get into that right at the end of the webinar. But since Mr. Narayan pointed this one out, I wanted to raise that point. We'll also hear from UPS in the words or directly from the CIO for UPS, Mr. Juan Perez.
Data plays a key role in the smart logistics network at UPS. Forecasting our package volume levels is critical to running an efficient network. Let me tell you how we leverage BigQuery for the most precise volume forecasting in UPS's history. We gather and analyze more than 1 billion data points every day, including package weight, shape, the size of our packages, as well as the location, the facility capacity we have across the network, and customer data. Google technology allows us to perform analytics on this massive data set while providing the platform and the capability to run machine learning different models across all this data. The outcome for us is really critical. The outcome of the forecast tells us exactly how to load our delivery vehicles, how to maximize the use of our assets, and how to ramp up our network around the holidays. Most important of all, it helps us make more targeted operational adjustments, minimizing the forecast uncertainty that comes with the unforgiving demands of e-commerce. The more real-time data we can get about the state of a package, the better visibility we can get into potential challenges, and ultimately, the better we can serve you, our customers. It truly is a brand new day for a smarter, more agile, and ultimately a more forward-looking UPS. Our future follows a path paved by prescriptive analytics. That's where we're going, which allows us to achieve true supply chain visibility and efficiency in moving goods between 220 countries and territories faster than ever imagined. We are grateful for the opportunity to collaborate with great partners like Google in a way that lets us use our joint expertise to bolster visibility across supply chains around the world. Thank you again for the opportunity to be here.
All right, that was pretty cool. I especially love that they're using ML models to predict and guide them on how exactly they load the trucks. So like not just guiding strategy inside of UPS, but also guiding very tactical operations in the company. I think that's awesome. Actually, diving a little bit deeper into UPS, I have another example that I wanted to share with you all in this webinar. So this company, Geotab, is actually a provider to UPS, and they're a telematics company. And what they do is they have a sensor box that UPS installs in all of its vehicles. As a matter of fact, this image on the right-hand side of the slide here is actually a point cloud of one day of their data. And so this sensor box obviously records position, velocity, humidity, air temperature. You get it. Like, it's a lot of variables. And the Geotab then collects all of that using Google Cloud and is able to deliver that to their customers like UPS to get those logistics and supply chain insights they need to manage their supply chain. But I wanted to point out a particular success story around Geotab, that they were able to bring geospatial analytics and ML together in a demo in record fast time. So I wanted to show you a demonstration of something that Geotab pulled together. They predicted hazardous driving as a function of weather conditions in 7 weeks. And that's the tagline here really is 7 weeks from what to wow. I proposed this demo to Geotab a couple of years ago, and I went to them and said, hey, we're launching geospatial, we're launching ML inside of BigQuery. I know some of your data. I think we can do something awesome. And 7 weeks later, they were on stage presenting this demo that I'm about to show you that pulls together these 3 different capabilities. So geospatial analytics, machine learning right inside of SQL, and then the public weather data that we have already inside of BigQuery. So a little bit of code. What they did was they created a machine learning model that would predict hazardous driving. Like, because they have these sensors in the vehicles, they can measure acceleration. So harsh braking or swerving from side to side qualify as hazardous driving. And they could predict a score based on things like at the bottom, at the second half of that select statement, based on like location, traffic volume, temperature, visibility, fog, rain, snow, i.e. from the weather. Okay, so let me switch over to the demo that they created. Okay, so here's what Geotab came up with. So we're going to be looking at hazardous driving as a function of weather. We're going to be predicting hazardous driving, I should say, as a function of weather. And this is for the city of Chicago. So let's pretend we're a traffic planner for the city of Chicago and we want to be investigating these troublesome areas. So let's dial up some weather conditions. I'm going to pretend that it is a cold day with fog and snow and extra traffic because maybe it's like the 20th of December and there are a bunch of people out for holiday shopping or something like that. And then we'll go ahead and run the predictive analysis, and we will see, based on those constraints, where we think the hazardous driving is. Now, a couple interesting things here. One, I-90 is pretty bereft of hazardous driving. That's awesome. It seems like people are handling themselves, or the model expects people to handle themselves pretty well on the highways. And it's the secondary and tertiary roads that are the problem. So we are going to literally parachute into one of these hotspots to see what's going on. So here we are at the intersection of Howard and Northwestern. And there's nothing about the map here that suggests this is a particularly troublesome spot. As a matter of fact, the troublesome spot isn't even on the main road. However, since this is Google, and this was implemented with the Google Maps APIs, I can just take the Street View avatar and drop them in, and we can go have a look. So here we are. This is Howard up in front of us. And as we pan around a little bit, we see that we don't have parallel parking. We have angle parking here. Perhaps this is part of the reason that there's a problem here, because that's something that's a little bit unusual about this intersection. So maybe as a traffic planner, we would be looking at this and saying, oh, well, I should make sure to plow this intersection extra well next year, or I should pre-position some sand. But I thought this was a marvelous example of using 2 really distinctive technologies inside of BigQuery to produce a really cool analysis. All right, so we'll go ahead and scoot back to the presentation. So that was a cool demo. As we're wrapping up here, I wanted to reiterate a couple points and then really drill in on this one. So BigQuery as a product has a bunch of functionality that are just what a data warehouse should do, right? Things like storage and query, partitioning, able to load your data, able to, and BigQuery's uniqueness, you can load a lot of data and query it. We also have these unique functionalities, real-time streaming, big machine learning, geospatial analytics, so that you can do more new types of analysis and get more and better insights out of your data. We can also deliver that with a lower total cost of ownership. This slide here shows a study done by ESG where they calculated the TCO of BigQuery and of legacy on-prem data warehouse and running that legacy on-prem data warehouse on VMs inside of AWS, and found that the BigQuery solution was 40 to 50% cheaper over that 3-year time frame. So this is what we mean when we say that we can deliver wider and better analytics to our customers for less money. And we can also support our customers through these migrations. As the gentleman from Home Depot said, it's not a trivial undertaking, and so customers need support through the entire, and acceleration through the entire process. So with the BigQuery data warehouse migration offer, we offer funding for training your people. We also offer funding for proofs of concepts. We have a professional services organization that can be your guide and your muscle to get you through this process. And we can also allocate 10% of the first year deal value to fund a migration or implementation partner. So if you want somebody else to help you migrate scripts or whatever, that is available. So I really hope you avail yourself of this opportunity to get the benefits that you see our other customers are gleaning by being on BigQuery and inside the Google Cloud Platform. And with that, thank you very much. My name is Chad. Be well, be safe. Thanks for spending the time.